Newton's second law of motion, the relationship between acceleration and mass. Newton's second law of motion states that when a resultant force acts on an object, it causes that object to accelerate in the direction of the resultant force. The aim of this experiment is to determine the relationship between acceleration and mass. We expect that as the mass of an object is increased, the acceleration decreases.
In this experiment, we are going to verify Newton's second law. And looking at the first part of Newton's second law, we're going to look at the relationship between mass and acceleration. And to do this experiment, we've got a trolley and that is tied through a pulley to a 100-gram mass piece. And what we are going to do is we are going to increase the mass on the trolley, and we'll watch what happens to the acceleration as we increase the mass. And to get the acceleration, we've got the trolley in front of a motion detector, which will then pick up the acceleration of the trolley, and it will give us graphs on the computer. And from those graphs, we will then get values of acceleration for each of the runs. And we'll run this trolley 4 times, each time increasing the mass of the trolley. So run 1, we are merely going to accelerate the trolley alone, and the mass of the trolley alone is 0.91 kilograms. So let's have a look at run 1. There's our acceleration graph for the trolley of mass 0.91 kilograms. We increase the mass by 0.5 kg and we watch what happens. There's your next graph. We repeat this. This time the mass is trolley 0.91 plus 1 kilogram. There you go. And the last run is 0.91 plus 1.5 kg. And there are your acceleration graphs. Right, if we take a quick look at the results, run 1, remember the mass was about 1.01 kilogram. This is now the mass of the system. The value that we take is the mean value. So the acceleration for run 1 is 0.60 meters per second squared. And then we increase the mass to 1.51 kg, acceleration 0.40. And then run 3, increase the mass to 2.01, and the acceleration there is 0.29 meters per second squared. And then the last run, the mass was 2.51 kg, and the acceleration there is 0.22 meters per second squared. So maybe you can take some of these results and plot a graph of mass versus acceleration.
If we take the points from the experiment and we plot them in the graph, that is acceleration versus mass of the trolley, we can see clearly that as the mass of the trolley was increased, so the acceleration decreased. If we invert the mass of the trolley and so plot the acceleration of the trolley versus 1 over the mass, we can see a straight line that goes through the origin. This means that acceleration is directly proportional to 1 over the mass of the trolley. In other words, acceleration is inversely proportional to the mass of the trolley.